It's time for us to talk about areas of polygons, all kinds of different polygons and circles. Now you've been dealing with areas since 6th grade, so this is nothing new. This should be a fairly good review, the final review. We'll extend it a little bit, but basically this is time for you to figure out what these things are, how they work, start memorizing some equations, because I can tell you if you're in honors, your next math class, if you've already had Algebra 2, will be Pre-Cal PAP or College Algebra and then AP Calc. And if you're headed to a career that is in higher level math, you're just expected to know these equations so that you can use them in that higher level math course. They're not going to have a formula chart with them on there. They're not going to have any little cheat sheet for you. You're just expected to remember these and to make them work. Why? Well, in calculus, you're going to be expected to be able to differentiate them, use them to solve dynamic problems, changes in lengths and widths and what's happening over time. In order to do that, you've got to know what the equation is. First one we're going to look at is just areas of parallelograms. Parallelograms, remember what those are? Parallelogram has, number 1, 2 pairs of parallel sides. Number 2, opposite sides are congruent. Number 3, opposite angles are congruent. Number 4, the diagonals bisect each other, I believe. And number 5, consecutive angles are supplementary. Alright, so you got that, and that's what a parallelogram is. Area of parallelogram is real simple. It's just simply base times height, where B times H, where B represents the base and H represents the height. Well, what is that? Let's talk about it. The base is one side of the parallelogram. Pick a side. And the height is the perpendicular distance from that base that you chose, that base side, to its opposite parallel side. Perpendicular and parallel here. Let's read it again. The base is one side of the parallelogram, and the height is the perpendicular distance from that base side to its opposite parallel side. So for the base, pick one of the sides. Doesn't matter which one. Here's some parallelograms where we've got these lined out. Here's one here. We chose the bottom as the base. What's the height? The perpendicular distance between the base and its opposite parallel side. Another way it can be shown here is we chose the bottom again as the base. We extended this on auxiliary and we drew an altitude from this vertex down to here and represented that as height. Same thing. Same distance as this represents. Now, can we choose the other side as the base? Sure can. We don't have to always use the one that's flat to us. We can use the other one, and the height is the perpendicular distance between this side and its parallel opposite side. Again, it doesn't necessarily, that height doesn't need to have to be measured inside of the parallelogram. It can be measured outside the parallelogram. This is the base, and we extended that, drew a perpendicular to this vertex, and there's our height. Okay? All we're doing is simply making this into sort of a rectangle so that we can do base times height. That's all there is for parallelograms. Alright? That's the equation, and that's how you apply it. Alright, let's look at some examples of areas of parallelogram. Remember, the area of parallelogram is base times height, B times H, where B is the base, H is the height. The height is the perpendicular height between the two bases that you choose. Which base can you choose? You can choose any side you want to be the base. The height is the perpendicular distance between that base and its opposite parallel side. So let's first of all take a very simple one here. Right here's a parallelogram. One of its sides is 32, and it's already been identified. Its height has already been identified as 15. It's perpendicular from that base that we've chosen to the opposite other side. So we have a base of 32, a height of 15. We simply multiply those two together. Altitude equals 32 times 15 equals 480. Very simple problem. All right? Now, let's take a second example. Have an example here. We're going to do it two ways. Why? Because we have a base of 20 and we have another side of 12, but we have this angle right here that is 30. Okay? Now, that means that this is a right angle right here. So that means that is a 30, 60, 90 degree right angle. Well, that's a 30, 60, 90 degree right angle. The side opposite the 30 degrees is 1/2 of the hypotenuse. Therefore, the base is 20. We're just copying that off there. The height is going to be 12 divided by 2 equals 6. Get out your formula chart and look at that. Guess what? In your next math class, you're just expected to know that, no formula chart. You're expected to understand where that is or to use trig functions. So what we've got is we've got 20 times 6 equals 120. Well, let's look at it another way. If we're standing right here on this 30 degree angle, what does the h and the hypotenuse represent? Let me see that. It's opposite and hypotenuse, so katoa. That's going to be so that's the sine of 30 equals height divided by 12. Height divided by 12. We rearrange that. Height equals 12 times the sine of 30. 12 times 0.5 equals 6, and we get the same thing. So two different ways to get that. All right? One, using it as a 30, 60, 90 degree triangle and using the table that we already know, or another one using trig functions. So let's do another one like that, except it's a little different. We've got another one. Turn it around so you don't get used to the same thing. We've got two sides, one side of 24, another side of 15. Now because of that, we could do this any way we wanted to, but we're going to consider this as our base. 24 is our base. And by the way, what's this side? This is parallelogram. Oh, we can move that over there, can't we? Or we can move that height right here and make this angle 20 and do it from this side. Either way. But let's look at this. We've got to somehow find out what that height is. We're given that this angle right here is 20. Okay? So we're going to have to do some trig magic to find out what that height is. If I'm standing right here on this angle, I have the opposite, which is my height, and I have this hypotenuse, which is 15. Well, what relates that opposite and the hypotenuse? So, katoa, oh, it's a sine again. So I have the sine of 20 equals h divided by 15. Rearrange that to solve for h. H equals 15 times the sine of 20. H equals 15 times 0.3420 or 5.13. So my height, got from my trig function down here, is 5.13. Now I can do my equation. 24 times 5.13, so the area is 123.13. Now, just because you're not given enough measurements, you're probably going to be given enough information or can get enough information so that you can calculate those measurements. You need to look for that. You're responsible for the trig functions now, and they expect you to know them. Now the next one is a little interesting. It's a little different in that we've got to go find the angle and then go find the height. We're given a fairly unusual parallelogram where one side is 20, the other side is 30, and it's arranged in such a way that for some reason, while they meet right there, and we've got, connects those opposite corners and it's perpendicular to the opposite side. So we've got a 20. Well, if this side is 20, that means this side is 20. Why? Because on parallelograms, opposite sides are congruent, as well as being parallel. And we're going to call this unknown angle here, between this 20 side and this 30 side over here, we're going to call that alpha. Greek letter alpha for unknown. Now we already know we're going to claim that our base is 20, so we're going to lay that out right there. But we don't know what this angle is, so we can't even calculate that. What? No, but we know what? If we're standing right there, this is the what side? That's right, the adjacent side. This is the what side? The hypotenuse side. So, katoa. Not opposite. Oh, adjacent hypotenuse. That's ka. So that's cosine. So we come over here and we say the cosine of alpha is going to be adjacent divided by the hypotenuse. 20 divided by 30. The cosine. Oh, we want to know the angle. Because we got to find the angle because we got to use the angle. We want to know the angle, so we're going to do the inverse of the cosine is 20 over 30. That equals our angle. Plug that into our calculator. We get the angle is 48.19 degrees. Great. Does that tell us what we need to know so we can calculate that height? No, we got to take it one more step. We now know that angle is 48.19. If we know that angle, can we find this? Yes, we can. Why? What relates the adjacent and the opposite side? Or the opposite and the hypotenuse. Either way. So katoa, we could have used the opposite and hypotenuse, which would have been the sine, or we could have used opposite and the adjacent, which is the tangent. I chose the tangent. Take your pick. The tangent of 48.19, because we're standing right here, is h, the height, over 20. Rearrange that. Height equals 20 times the tangent of 48.19. The height equals 22.36. So we finally have our height of 22.36. Multiply those two together, and we get the area is 447.22. Now this is a little busy. This is the first step. We have to find out what that angle is. Once we find the angle, then we can use it to find the height. We could have used either the sine of 48.19, and that would have been h over 30, and gone that way. I chose to use the tangent of 48.19, which is h over 20. Find the height, then we can plug the height back into our equation. Now, there's nothing new here. Nothing at all. Here, oh, it's just an equation, plug and run. This one, oh, we're given an equation, we're given an angle that lets us know it's a special right triangle. We're supposed to know those special right triangles. We can apply that, or if we forget that, we can use our trig ratios to find out what that is and go. Trig ratios are not new. Only thing new is that equation. Wow, apply it. Here, nothing new. You know this is a parallelogram, so this side equals this side. You know what's going on here? Bang, there's that. Find out what this height is by using your trigonometric ratios. Trigonometric ratios are not new for you. We're just applying what you know. That's what the rest of this year is going to be about, is applying what you know. Down here, wow, we've got to do some extra steps. There's 1, 2, 3 steps on this. Okay? 3 steps. You've got to, oh yeah, well I guess there's 4 there if I have to do that. Then I have to find the angle, then I have to use the angle to find the height, then I have to apply the height to get there. So that's a more complex. Well, guess what your test questions are going to look like? That's what they're going to look like. Can you apply the knowledge you have and what you have learned this year to solve these problems to find the area?